Okay, this was the last quiz question of the day. It says pure A and B have a vapor pressure of 100 and 150 torr respectively, and they form an ideal solution when mixed. And if the mixture of A and B has a total vapor pressure of 135 torr, what is the mole fraction in the liquid phase? Okay, well, what do we know about this? First of all, we know that it's a binary solution. We know that it's an ideal solution. So it seems reasonable to assume that the answer is going to come from one of our equations having to do with binary solutions that are also ideal. So if we want the mole fraction of B, that's going to be, according to our earlier equation, the total pressure minus vapor pressure of pure A, vapor pressure of pure B, vapor pressure of pure A. And I had to switch these letters around compared to the equation that I gave you from the binary ideal mixtures, because we're looking at it from the perspective of B now, not A. So I had to switch around the letters. Okay, let's plug in our answer here. 135 torr minus 100 torr divided by 150 torr minus 100 torr. So what does that equal? That's going to give us 35 torr divided by 50 torr, which is just 0.7. So therefore, the correct answer is 0.7 for the mole fraction. Okay, to review what we talked about today, we saw that a tie line exists between a liquid and vapor phase of a mixture, and that the tie line shows us what the mole fraction is in the liquid and also in the vapor. Remember, Y is for vapor, accentuating that Y sound, vapor. We also saw how to use the lever rule in these 2 points here in order to get the total mole fraction Z of component A. We also took a look at the colligative properties and saw how that depends on the molality of the solute and also a number of other characteristics of the solvent. We saw how activity needs to be used to express the chemical potential for real solutions, and we also saw how to use those chemical potentials in order to get a new kind of equilibrium constant. This one for solutions using concentrations instead of mole fractions or partial pressures.